EVDO Revision B was first deployed in Indonesia in 2010. It is a multi-carrier evolution of Revision A. High data rate per carrier as well as downlink peak can go up to 4.9 megabits per second per carrier, and the uplink peak can go up to 1.8 megabits per second per carrier. EVDO Revision B performs well because it has reduced latency from statistical multiplexing across channels. What that means is that without statistical multiplexing in the former version of it, when you have multiple channels that needed to send data, well, in that case, they were assigned certain slots, and these slots were dedicated to users. Well, if a user did not have anything to send, that slot would have been empty and it would have been wasted. In statistical multiplexing, what they do is that the devices that have something to send, they send it and it gets stacked up. And whoever has something in request in the queue, that gets sent in that order. So therefore, there are almost no wasted slots based on statistical multiplexing. So therefore, the efficiency of using the resources goes up, which is great. This means that it has reduced delay and improved quality of service. Longer talk time and standby time is enabled. Hybrid frequency reuse and reduced interference at cell edges and adjacent sectors were enabled through EVDO Revision B technology. So therefore, at the cell edge, the quality of service is enhanced significantly. More efficient asymmetric data rate support. Once again, asymmetric means that the downlink and uplink data rates are not the same. And of course, this is the case. And you can even have a higher flexibility of asymmetric capability where you can increase the downlink even more or reduce it to support a little bit more on the uplink data rate. Asymmetric services come from file transfer, web browsing, multimedia content delivery, and other places. Just for example, when you're browsing a website, you may not have downlink all the time. Well then, when you have something to download, you need a lot of download capacity. But after you downloaded that onto your device, you may not have much to download further. Then in that case, the uplink can take advantage of the leftover capacity to send more at a faster data rate back from the mobile device up to the base station. Long-term evolution is our next topic. And a lot of devices that are available now are based on this technology. This was launched in North America in 2010 with the Samsung SCH R900. This was deployed on both GSM and CDMA mobile operators. So therefore, it has backward compatibility with 3G and 2G devices and networks. The peak data rate based on release 8 is a downlink of 300 megabits per second and an uplink of 75 megabits per second. As you can see that the peak data rate ranges have gone up significantly, where the data rates are in the larger hundreds of megabits per second for download and at a large rate for the uplink as well, in the 75 megabits per second range. Then we have LTE, which is LTE Advanced. From this standard, this is considered fourth generation. And it is based on the ITU-R IMT Advanced process. Based on this overall category, this technology has a peak data rate, based on release 10, of 3 gigabits per second downlink, and uplink is 1.5 gigabits per second. As you can see, reaching into fourth generation mobile communication puts us into peak downlink and uplink data rates that are in the range of gigabits per second. So from kilobits per second in the second generation, we went into megabits per second and tens of megabits per second in the third generation. Now we're going into the fourth generation, which now enters the range of gigabits per second. In the following lectures, I'm going to talk about the details of LTE, LTE, and the future fifth generation 5G mobile communication technology in further detail. LTE incorporates high-order MIMO technology using 4x4 antennas and more, meaning that on the mobile device you have 4 antennas, and at the base station you have 4 antennas or more. And this allows multiple carriers to be bonded into a single stream. And that is how we get gigabits per second data rates for uplink and downlink. These are the references that I used. And in my following lectures, I'm going to focus more on LTE, LTA, which is 4th generation mobile communications, and the future 5th generation mobile communications, 5G. So please go into the details of those because that's the future and that's where all the money is going to be invested in for high advanced mobile communication services. I'll go into the details of that. Thank you very much.